class. What did we do yesterday?
We learned SQL.
We started SQL. We started going through Khan Academy. What are our 4 fundamental SQL operations? We haven't touched on all of them yet, but what are those concepts that we are touching on?
CRUD.
CRUD. What's CRUD stand for?
Create.
Read.
Read,
Yeah,
update,
create.
delete.
Beautiful. That is going to be everything that our database is doing. So we're going to keep going on Khan Academy. How are we feeling about Khan Academy in general as a learning resource? Do we love it? Do we hate it? How do we compare it against Free Code Camp? We feel like it's a good pace. How are we feeling in general?
I loved it.
I like it.
Good. Good.
Yeah.
Well, that's very good news because we are very much continuing that today. So we're going to keep going on SQL. The goal is to get through most of the SQL syntax today and a little bit of tomorrow. So next week we can start getting into database design. We're going to learn about entity relationship diagrams. We're going to start talking about modeling and normalizing data. And then from there, we get into how do we integrate that into our capstone, right? How do we store data? How do we get that flowing through the API? All of that stuff. Any questions on either anything that we reviewed in React yesterday or any of the content last night? Any questions before we dive back into Khan Academy?
Yeah, so I was looking at the thing you wanted to do with the edit and delete, and I'm able to, when I do the edit, I'm able to store the message in a variable, but I was kind of lost of how to get that actually into the message text as opposed to just being in a variable.
Do you want to share your screen and we can spend 10 minutes on that? Because I think that would be good for everyone to see. And I'm going to just request remote control if you don't mind. Okay, so you're definitely on the right track here, right? You've got your span tag that's firing off that edit clicked function. You've got the edited message there. And now what we need to do is figure out where we can get that edited message to update our actual message text right here. So where is our message text coming from?
Line 17.
Line, oh, this is the edit clicked function, but where does the message text come from right here?
It's coming, isn't it not coming from line 17 with the messages being sent in? And
So
then
this is where the edit clicked function is, but our message text shows up right here. Where does that message text come from?
All right, so maybe I'm missing something constantly. Right up here with the mess. I don't know.
I'm sorry, you are right. It's coming from 17, which is a prop. That prop comes in right here. Where does that prop come from once we get to line 10?
It comes from line 10. It comes from line 3, right?
Line 3, which is coming from
the app.js, I believe.
Correct. Yeah. So it's really trickling down. It's a far path down, right? Where it's really coming from is our messages, which are coming from state. So it comes from the state down into the messages list. From the messages list, it comes in as a prop, which gets mapped over as the individual message, which then gets sent down in as another prop into the sent message. The sent message then gets that prop and has it show the message text all the way down here. So through that entire chain all the way down, line 36 is where it actually finally shows up. But really where it's coming from is our use state right up here, which is saying my first message, my incoming message, and all of that stuff. So this message text is actually trickling down through all of those props from our app down to our messages list, from our messages list into our map, into our set message, our sent message, all the way down to the render where that message text is showing up. So in order to be able to update all of that, we not only need the message text here, we also need the ability to update all of that, which is from this set messages function. So what we need to do is figure out how to pass that set messages all the way down so that when we are using the edit function right here, we're able to call set messages. Does that make sense?
Yeah, so can we
Let's
just?
skip course where you're gonna,
I'm sorry. Yes, can we just send it in as a prop then to the?
We sure can. So what we're going to do is just like we send in messages, we are also going to send in set messages. And then in our messages list, we've got to tell it, hey, you're going to get another prop called set messages, excuse me, and that needs to go in all the way to the sent message as well. And then we're going to tell set messages, hey, you're also getting that prop. And so now here, we need to keep track of one more thing. That is what message is actually getting edited, right? So in order to know that, we are also going to send in one more prop here, and that is the index. So down in here, what we can do is we can say, hey, our messages updated is going to be a copy of all the messages. So we actually need one more prop there. And what we're going to do is we're going to copy all the messages. We are then going to update the messages with the index to whatever our edited message is. And then we are going to set messages to our messages updated. Okay, that was a whole heck of a lot that we had to do there. Let's take a step back. So first things first, in order to get our messages to update, we know we have to use this set messages function. But the problem is this set messages function is all the way up in app, our most parent component. So what we do is we send down that set messages function as a prop into our messages list. When we send that down in our messages list, we need to tell messages list, hey, you are going to get a function called set messages. Okay, now that you've got set messages, we need to pass that set messages down into the sent message. And we also need to send down all the messages, not just the individual one. Okay, now that we're there, we need to tell it, hey, sent message, you are going to get all the messages and a function called set message, plus the index of whatever message this is. Is this the first message, the second message, whatever? From there, we already had this prompt working, right? This is storing whatever the user updates the message to. But because messages is not editable directly, what we do is we essentially make a copy of the messages, the entire array. Then we use the index, which is coming in from the prop right here, to update the message based off of whatever text is coming from the prompt of the window. Finally, we take that updated messages array and use set messages, which is coming in from our prop, to update that in the state. Give me some feedback there. Does that make sense? Is that
It makes sense. I
Makes
don't.
sense
I
now
would
that
have figured
you
it out on my
said.
own.
I would, yeah, me too. No joke about that one.
so? The main trick here is there are 2 or 3 main concepts that we want to visit here. The first one is the data that we're talking about is in state, right? State is that React concept of if this date gets updated, if we update the data that is living inside of the state, everything just magically updates for us. So remember back in the day, we had update HTML, and anytime we would change our data, we had to regenerate all of the HTML. That is what state is doing for us. Whenever we use this set function, that set function is triggering the update HTML for us. So we don't actually have to update that HTML. The problem that we run into is, hey, set messages is all the way up here in the app, but really where we want access to it is all the way down in the message itself right here. So what we do is we pass that function down through the props right here, so we get access to it all the way down in sent messages. So that is state and passing state via props. The third notion of state that we're using here is that we can't edit the state directly. We can't just say messages index is equal to whatever we want. State cannot be modified directly. So instead, what we have to do is we make a copy of that array from the state. Now that it's copied out of the state, we can make any of the changes that we want to it. And then we take whatever that copied version is and set it back into the state. Now, because we are not modifying the state directly and we're using this set function, what you will find is if we go see what's happening in the browser here, Larry, could you pull that browser window over?
Yeah. 1 second. This happened. I think I accidentally closed it. I hope I didn't. Oh, that's not it.
Just go local. Here, let me try something. I should be able to pull it up. Just doing localhost 3001. Yeah. Okay. So now you've got my first message here. And if we hover over that, we should get the edit button. And if we click edit, go ahead and type in something. Okay. So whenever we get a white screen, this should be a reminder to go into inspect and go into the console. And now we've got an error here that says, cannot read properties undefined of toString. Okay, so let me just hop back into your code still back here. So what we ran into there is we said, hey, the message, the entire message is going to equal whatever our edited message content is. But if we look back in our app.js, you'll see we've got an object here. It's not just a string. So we don't actually want to update the timestamp or whether it's received. We only want to update the message text itself. And so that's what I forgot to do in messages list. Instead of setting the entire thing equal to whatever the new edited message text is, instead, what I want to do is only update the text key that is inside of that object. So now if we switch back over here and refresh and try to edit this and just say test, come on, and hit OK. Now it updates.
Okay. Thank you. Now, let me do something real quick. Okay, so whatever message we hover over, it will have the edit or the delete option. Okay.
Yep.
Thank you. Still head spinning, but I followed the path, but I wouldn't have figured that out on my own. At
Okay,
least
so
not with a
let's-
lot of YouTube.
And this is something that I think Christy was asking about, right? Of like, I get all those concepts, I get state, I get props, but how do I go about doing something like that? So once I get something like this working, here's what I would do. I would say, come in here and I would say, and Larry, apologies in advance if this is too detailed, but I would say, number one, add set messages prop so we can use it in each individual message. Then I would say that was the first thing that we did out of all of this, right? Second thing that we did is we went into messages list and we said, oh, no, that's not what I wanted to do. Come on. Number two, actually, need to do it all the way up here. Add set messages prop that is getting sent from app.js, right? And that was number two. Number three was pass prop from app.js through messages list to each individual message. And then number four, pass index so we know what message to update. Then number five, update incoming props list so we have access to index and set messages method. Number six, collect what the edited message content should be. Number seven, copy the messages array from state because we can't edit variables in state directly. Number eight, update the specific message index text to include our updated content. And then finally, number nine, update the copied array with our updated message text back into state using the method passed in the props. Now, I don't know if that's helpful or not, but doing that line by line breakdown, going through tic-tac-toe, going through any of the projects that we have done and writing out these steps are going to be so important for you to not only understand what each one of these lines is doing, but thinking like that as an engineer. Okay, my boss just told me that there needs to be an edit button on the sent message. Okay, how do I go about doing that? I need to add the edit button. Then I need to go in and figure out what they want to edit it to. Then I need to figure out how I get access to the data. Then I need to update just that specific index. Then I need to set it into state. And so being able to go through and just add that step-by-step breakdown, even if you hit 100 steps, doing that line by line breakdown is going to remind you what each one of those lines is doing and get you more comfortable with, if I make a project from scratch, how would I go about doing that?
Thank you.
Is that helpful to anyone else to kind of see that? Does anyone else see the way that I think about it when I write out those steps?
Yeah, we can see how you think about it.
Does that connect? Do you guys think about it a different way? Now that you see it working, do those steps help, or are they just more confusing?
They kind of make more sense now because it kind of gives you an idea of like what you weren't thinking about. not laughing, but you know, yeah.
So doing that level of breakdown is what I would be doing on each project, right? Actually going through and making sure, hey, line by line, do I understand what order I did this in? Because the order of the steps is 10 times more important than the actual, I can read this code from top to bottom. Any questions on this? Does this give you a better idea of how you would go about making the delete button work?
I mean,
I have a
I'm gonna just do someone I'm a request, yeah. Definitely, yeah.
I just have a quick question. I'm not sure if it is yeah or not, but
This
I
is
feel
me.
like I definitely understand the sent part, just like going over it, but was there a different part of the code that you might have did differently, Larry? It's like two ways to do certain things. Can you scroll up? I don't know. It was like the equal part. Oh no, maybe it's just separated. Okay, I see. Never mind. Because I don't know if it was another project me and Larry was going over and he had did it a little bit slightly differently. So I'm trying to like make sure I differentiate like when I'm getting help, or like from
This
when
is
you
pretty
are.
similar to how we did it in class, if not identical. So
yeah, this is how we did it in class. I just added the edited message part before he took took control and showed us the rest.
Okay, yeah, no, it looks pretty familiar, definitely. But thank you. I was just
You're
making sure.
that I think I broke comments on lines 3 and 4. It didn't like the fact that I inlined those. So just if you have a syntax error, it's the comments 3 and 4 that are causing issues. Just so you know, Larry.
Okay,
And-
thank you.
By the way, this is a great use of one-on-ones, right? One-on-ones don't just need to be a status update. You can schedule one-on-ones and be like, I'm stuck on this homework assignment, or, I started this and I got it working, but I still don't understand what it's doing. Or I will say the number of one-on-ones this cohort compared to the other two is definitely down. So feel free to schedule one-on-ones with me, right? The link is right in Canvas. Reach out, just jump on my calendar, even if it's only a 15 or 25-minute one, right? And we can work on either getting you caught up on homework or reviewing homeworks that you may have done, but just need to go over those concepts a little bit more.
Even getting organized.
Yeah, I'm
Yep.
gonna have to do that. Thank you, Max.
Awesome. Any other questions? Any other homeworks that you want to review before we dive back into SQL?
I'm gonna just say like we should probably keep it going because I feel like I'm okay with SQL and might as well keep it up. I'll get back to the other stuff later.
Sanjay asked, Larry, is that prettier outlining like that? I believe you had prettier on because when I saved, it did a lot of the indentation for me.
Yes.
Okay. And Christy asked if you could share the code. If you can just drop app.js and messageslist.js into the Slack live stream, everyone should be able to get access to it there.
Okay.
Awesome. So give me 1 second and we will pull up Khan Academy and dive back into that. All right, so we are kicking off with aggregating data.
We're back with our grocery list. I can see that it has 6 rows in it, but I can also see that we need to buy more than one of each item, like our bananas. So I'm not sure offhand how many items we'll end up buying total. And I'd like to know that total number so that when we're cashing out, we could just do a quick check to see if we have the right number of items in our cart. Well, to do that in SQL, we can use what's called an aggregate function. An aggregate function is useful for things like getting the maximum, minimum, sum, and average of values in our database. In this example, to get the total number of items, we'll start with select, then the name of the aggregate function we'll be using, sum, then the name of the column we want, and then from the name of the table we're selecting from. Ta-da! So we can see on the right that the sum is 15, so we should have 15 items in our cart if we got everything correctly. And notice if I go up here and change the number of bananas, because I'm going to invite my monkey friends over for a jungle party, we can see the sum increase in real time and get bigger and bigger, so we know that we're now going to need 67 items in our cart. Now we could easily try out other aggregate functions here, because sum's not the only one. So if we wanted to know what is the most that we'll be buying of any one item, then we could use max. See, 56. Those are obviously our bananas. But this information is useful for this case. Let's go back to sum. Okay. Now, what if we wanted to make sure we had the right number of items after each aisle? Well, we can do that in SQL using the group by clause. We add it to the end of a query, specifying the column name to group by aisle. Okay, so now we can see that in one aisle we have 9, another of 1, but I don't actually know which aisle we're getting each of them in. So what we can do there is just add aisle to the beginning of this select. So there you can see, okay, so we're going to get 9 items in aisle 2, 1 item in aisle 4, 56 in aisle 7, and 1 in aisle 12. Awesome. Now, how did that actually work behind the scenes? The SQL engine first did the grouping of the rows based on aisle. So first did this group by, then it summed up the quantity in each of those groups, and then finally it selected the first aisle value that it saw in each group. And the aisle value was the same for all of them, so we got the aisles back out. But we could have also said name here, and we do see a name for each of the rows, but it's a bit misleading because for some of these aisles, there are actually multiple items in that group, but the SQL engine just picked the first item out of it. So you really shouldn't be using something different from what you're grouping by, because you might not get a sensible result. So we'll say aisle, and now that's an accurate presentation of our data. Okay, so great. You've seen aggregate functions, you've seen group by, and now you can efficiently gather useful statistics on your data. Another tool for your SQL toolbox.
Sorry, my unmute button disappeared in Zoom. Okay, any questions about that before we dive into the exercise? You could hear that audio, right? Okay, good. I thought one of you would comment if you couldn't hear it, but so we're starting to look into some additional queries here, right? The ability to use some aggregate functions and say, hey, we want to add up all the quantities. And then also, well, how do we add up quantities? We need the ability to group them together. So we're going to spend a couple minutes and go through the challenge unless anyone has questions or needs a review on the video we just watched. Okey-doke. Go ahead and spend a couple minutes on the challenge. I just dropped the link in live stream and in chat in case it is easier for you to get to it that way. And I will also kick off the poll so we know how you guys are making out. And I will leave this screen up in case you want to reference what happened in the video. And don't forget to vote in the poll if you're able to get that working. Reminder to vote in the poll, just so I know how many of you guys are done so we can move on. Poll is in Zoom. All right, so let's move on here. So challenge, first part, right, was saying, hey, insert another item to your to-do list with the estimated minutes it will take. So a couple things we've got to do here. We got to do another insert into, right? Insert into, because those are SQL keywords. We're going to do them in capital. And then we need to tell it where are we inserting it. That's going to be our table name. So to-do list is the name of our table, and then we tell it what values to insert. Now we just have to be careful here because the ID is meant to be unique. So we have to make a unique ID, and then we're going to say learn SQL. And how many minutes is it going to take? Let's say that's going to take 20 minutes. Okay, so now when we put our semicolon in, we can see, hey, if we do a select star from our to-do list, we are able to see there is our learn SQL that we added in. So if we want to see the sum of everything, all we need to do is say, hey, give me the sum of all of the minutes from the to-do list. And so what that's doing, if we add in another select here, we could say select all the minutes from to-do list, and that's showing us 15. So 15 plus 20 plus 30 plus 50 plus 20 is giving us our sum of 135 minutes. Any questions on that before we move forward? Okie doke, on to the next video.
At this point, you've probably heard me pronounce SQL two ways, SQL or SQL. Some of you might even be mad that I'm pronouncing it one way or the other, and you may have very good reason for believing that your favorite pronunciation is the correct one. So what's the deal? Well, SQL was originally invented at IBM in the early 1970s, and the first version was called SEQUEL, and it stood for Structured English Query Language. That acronym, SQL, was later changed to SQL because SQL was already trademarked by an airplane company, and companies really don't like getting into trademark lawsuits. Nowadays, many of us still pronounce it SQL because it's shorter to say, and we've got historical reasons to claim that it's the right way. However, when I surveyed developers across the world, I found that in non-English languages, many of them pronounce it SQL, or, for example, SAQLA in Spanish. Since our videos get translated here on Khan Academy, I figured I'd make it easier for translators to match the pace of our videos by pronouncing SQL the long way. But in everyday life, I'm used to calling it SQL, so both of them come out of me. Now you know, it can be SQL or SQL, and you'll probably hear both the rest of your life. The world is a messy place, but at least you now have a way of structuring your queries about it, right?
I know that that seems like a silly topic to spend a minute and 40 seconds on, but that is very true. You will hear in job interviews and all over the place, both SQL and SQL said as a word. They mean the same thing whenever you write it. However, you will be laughed at if you say you know SQL on your data on your resume and write out SEQUEL. That is not okay, right? So whenever you write SQL, you always write the letters SQL, but when you pronounce it, you can actually say SQL or SQL, and both of them are understood. Okay, so this is a little bit of a project. This is going to take us a couple more minutes to go through. I'm going to give everyone like 5 to 10 minutes on a jump start on this to start working through it. And then I will come through and talk through the explanation of it. With that said, let me give you guys an option of, do you want to just see me work through it, or do you want to try it on your own? Let me create a poll for that. All right, poll is live for figuring out what you want to do next. $14 students in, 9 of them have answered. Oh, in traditional form, you guys have split the vote. We've got 10 votes in. Hopefully we get, I think, 2 more students voting. Okay. We are leaning towards me just doing it. So I will talk through this. Okay, so first things first, when we are designing our own store, we've got to figure out what kind of data we're storing, right? So they're saying it should sell one kind of thing, clothing or bikes or whatever. I'm going to sell microchips, because why not? You should have one table for all of the items in your store and at least 5 columns for the kind of data you'll think you'll need to store. You should sell at least 15 items and use select statements to order your items by price and show at least one statistic about the item. Okay, so first things first, what do we need to do in order to be able to store our data?
Make a
table.
Make the table. Okay, so what we're going to do is we're going to say we are going to create a table called items. And what do our items need? Well, almost everything in the database needs an ID. IDs are almost always integers in SQL, and they are going to be the primary key. This is telling the database down the road, hey, if we need to link some of this data together, if we need to relate this data to something else, this is the primary key. This is the way to do it. We also are going to need an item name, and that's going to be text. Let's say the item also has a price, and that is going to be an integer. We may have a quantity of those items, which is also going to be an integer. And then we can say something like, I don't know, maybe the color of the chip, which is going to be text. So now our database schema is popping up and we've got our 5 columns in it. What do we need to do next now that we've got the table?
Insert the data.
Insert some data. So we're going to insert into our items and the values that we are going to insert. And these go in the same order of our columns, right? So 1, and we're going to call this, I don't know, chip 1. The price is going to be $10. We're going to have 1 of them in stock. and the color is going to be green. Now, you notice up here, our items went to row 1, but in order to prove that our insert worked, what we can do is select star from our items table and see, hey, our query worked. Now, up in the requirements, it says, hey, we should sell at least 15 items. So what we are going to do is just copy this insert statement. But it's yelling at us because it's saying unique constraint failed on columns items ID. Well, that failed because all of our IDs are the same. So really what we need to do is go through and make sure that each one of our items has a unique ID. And when we get into actually practicing outside of Khan Academy, we'll actually see how the database uses something called auto increment to increment our IDs for us. Okay, now for the last part of this assignment, obviously we would want to go back in and not call everything chip 1, and we would want to update, let's say, our prices, right? So that will make it easier. 15 items, select items by price and show one statistic about that. Okay, so we'll just start with this. And there is an error. Semicolon. Okay, so now all of our chips are in here. How would we go about adding up all the prices together?
Sum.
Yep. So we're going to say sum of all the prices, and that adds up to 300. You can see how quickly these queries run. Okay, what they wanted us to do, though, is use a select statement to order your items by price and show at least one statistic about the item. So what we're going to do is, let's say the statistic that we want to show is the quantity of the items. And we would need to be able to change some of those quantities in order to see that change in our data. But now they also want us, let's say we want to show the quantity and the ID and the name of the chip. Okay, so now all of that data is coming back in our query. For the last part here, they want us to order our items by price and show one statistic. Well, we're already showing the one statistic. How do we modify our query here in order to order the item by price? All we need to do is add an order by and add in the price here. And now you notice our IDs changed in order here, but there's no real way of knowing whether or not this order by is working unless we also include the price as part of our select statement. And now because price is part of the select statement, we can see, hey, the more expensive chips are down at the bottom and the cheaper chips are up at the top. Any questions about that?
And one of the select statements, you use the asterisk or star. What, why do you use it for that one and not for these ones?
Yep, we can use it here. The select star is just going to select all of the columns in the table. We always need to specify something here. If we want all the columns, we use a star. If we only want certain columns, for example, we may only care about the name of the chip and the price in the chip. And so if we only care about those two pieces of information, we can just specify the column names, and that will limit the data that comes back to only those columns.
Got it. Thank you.
In general, you want to select the fewest number of columns possible. That just is the less data that comes back from the database, the quicker the query can run. Any questions on any of that?
Is there a, and I'm sorry if I forgot from yesterday, how you knew to use order by or whatever you're going to put there. Is there a spot where we can pull all of that from?
The order by we learned, I think in the aggregating data lesson, I think they used the order by, but
Mhm.
that was definitely touched on in one of the previous videos here.
Okay. Okay, so these were just in video. So there's not some place where we can just kind of check, like if we had a future project to where to get all the,
W3 Schools, let me confirm, W3 Schools does have a SQL tutorial. And
Okay.
this is going to be very similar to your HTML reference. This is a great question. SQL order by, you can see, is one of the things right here. And they will
Okay.
give you the breakdown of not only the select, but also the column. And then there is an optional if you want to sort ascending. This bar means an or. So if you wanted to sort ascending or descending, you could add that into your order by query. And they've got a whole demo database here, so you can actually try it yourself and play
Okay.
around with the order by query and see what the results are coming out of the table.
Okay, thank you.
W3 Schools, great reference for SQL as well.
All right.
Yeah, and Zach, you asked that ascending or descending question. So if I wanted the higher numbers up at the top, I could just say descending, and you'll see the change of the queries now have the highest prices at the top. By default, if you don't specify anything, it will always sort ascending. But if you want the descending sort, i.e. the most expensive ships up at the top, you just specify DESC, short for descending. Any questions on any of that before we move on?
Yeah, can you go up back to the first select? I'm just trying to see.
This
Okay.
is the only select.
Oh, okay, it's the same. I thought I was missing a star. Okay.
Oh, if you wanted to select everything, you could just select star from items, and that would give you this table, which is selecting all of the columns.
Oh, okay, thank you.
Star just means select all columns. If you do not include the star, you need to include the column name going on right here. Any other questions on that?
I use the same statement that you used, but it's telling me that I have a syntax error near insert.
Go ahead and share your screen.
Okay.
So you didn't finish your select query. Select star from where?
Oh, wait, so that was, so I would put, oh, I forgot to check items, but that was there before.
You are also missing a semicolon at the end of line 1 and line 7 now.
Oh, so the semicolon needs to be up here?
Mm-hmm. After every SQL statement, you need a semicolon. There you go.
Oh, okay, thank you.
I have a quick question too.
Yep.
After I see yours again.
Do you want me to share
Yeah,
mine again?
Did you, yeah, really quick, you had two columns, just the chip column and the price column. There was no extra column, right?
No, I had,
A price column?
where is this the right one?
'Cause-
Yeah, I had several columns. I had an ID, I had a name, I had price, quantity, and color. But what I selected was just name and price.
Okay. But can I show my screen? I'm not sure
Yep.
why my extra things didn't come up as well.
Yep, go ahead.
I'm missing a comma here, maybe or something.
Nope, that should come out. So you inserted ID, name, price, quantity, color. So all of that is good. And then you did a select name, comma, price from items. And that's the first thing that came back. And then you did a couple more inserts, and then you selected name and price again from items and ordered by price. And so that's what's coming out over on the right.
Again.
Yep.
So I have to choose, not price, probably color.
Yep, that would change it.
Is
Now,
it gonna
keep
be-
in mind, all of your chips have the same name and the same color, so that's why they're coming out multiple times,
Oh, okay.
which is what I did in mine, right? I was lazy and didn't update all my data, but all the chips would, in theory, have a different color or a different name.
But how come you see at the top where mine says name and price and name and
Yep.
color? How come it still isn't just naming them all? I have to name them all here too.
Do you want all the columns to come out?
Yeah.
So
right?
then delete out name, comma, price and put a star instead.
Oh, okay. That's what it was. Sorry.
And delete out price as well. And now if you scroll up, that's your second query, but your first query has all of that data in it.
Thank you.
Could you do the sum again? Let me see.
Sure. Oh, sorry, I didn't mean to share the whole thing. Let me just share. So here, if I wanted the sum of all of my chips, I would select the sum of the price from my items.
Okay. Sum, and then you. Try that.
Any additional questions?
I got a offhanded question.
Yep.
Um,
I've
when
got
I
an
was-
offhanded answer.
I bet you do. When I was creating the insert lines, one of my lines I didn't have like the last two, I don't know what to call them. the
Values.
things like, okay, yep. So let's say I didn't put like an IOL in quantity or, depending on what we're dealing with.
Yep.
And I had gotten an error for that. Is there ever a case where maybe you wouldn't have something that you put in? Like what would be the placeholder, or do we just do 0?
Yeah, the placeholder. Oh, this is a loaded question. Is it going to let me get away with this? Yeah. So null is when you don't have a value specified. This is kind of a loaded question because when you create your table, in addition to having the data type, you can actually specify whether null values are allowed or not. But if we, I think by default, they will allow you to have null. So in this last one, if I didn't want to specify, let's say, this chip is out of stock. So I don't have any quantity and I don't even remember what color it is anymore. You can use null instead of a number or a string, and that will tell the database, hey, that value is essentially empty. We don't have a value for it. Does that answer your question? Chantina, does that answer your question? You're unmuted, but we can't hear you, just so you know.
I'm sorry, I heard that. It was still, I was so into what I was doing, I forgot to plug back in my computer. I apologize.
No problem. Did that answer your question?
Yes, it did. It was still, I could still hear it, but it was turning off. I'm sorry.
You're fine, no problem. I will say that that is the most frustrating part of doing any kind of like programming support, is that when you answer someone's question well enough to get them unstuck and then never hear from them again because they're on to the next thing. And so you're like, I guess either you didn't like the way I answered the question, or I answered the question perfectly and you're just like on to the next thing. So I'm glad it was the latter.
And we don't need to do this spin-off. This isn't going to tell us that it's correct, right?
Nope. You don't need to do the spin-off, and this is not going to be homework. We are going to be using another coding platform similar to Khan Academy for the homework for this week. So you do not need to follow along with me or have this Done. Okie doke. We are on to the next one unless there are any other questions.
No.
Okay.
I've spent the last few talkthroughs making a grocery list. Well, now that I've realized how much eating I do, I realize what else I should be tracking in a database. How much exercise I'm doing. So I'll start by pasting in some statements that create a table and insert a few rows of data. Let's see what I have in exercise logs. We have an ID, of course, a type, which is a string like biking or dancing, minutes for how many I spent, calories for how many I burned, and heart rate for how high it went. Now I'm inserting the data using a slightly different syntax than before. Notice how I'm specifying the column names in parentheses after the table name. When I do that, it means that I don't have to specify every column value here. I only have to specify the ones that I give in this list of column names. Now, do you see which one I didn't specify here? The missing column is ID, and that's very much on purpose. ID, here we go. The ID column is the primary key in the table, and it's set to auto increment. That means that the database will automatically fill it in for us when we tell it to, by picking an ID that's different from the other rows in the table, usually a number that's one bigger than the biggest number so far. Now, I would rather have the database figure that out than have me figure it out. So I usually like to do my inserts this way, leave out the ID, let the database do that work for me. Okay, so there we go. My database table is set up, and it looks like I've even done a bit of exercise. Go me. Let's find out where I'm burning the most calories with a simple query. I'll just modify this one. So select from exercise logs where calories greater than 50, and we'll just order by calories as well. Okay, so I've done 2 activities where I've burned more than 50 calories, and it looks like dancing burned the most. Now, I want to find out which activities I've done that have burned more than 50 calories, but also taken less than 30 minutes, because I want to exercise more efficiently in the future. It's pretty obvious from looking at the current results. There's only 2 results. It's easy to look at that. But just imagine that there are thousands of rows. Maybe this is data from thousands of users. I would need a way to filter that down in the SQL query itself. To do that, I can use the AND operator to combine those multiple conditions, like to only return the rows where calories are greater than 50 and minutes are less than 30. Haha. So now I only see one result, dancing, which means I should just spend my whole life dancing, which sounds pretty good to me. Okay, so in a similar way, I could use the OR operator to return rows that meet any of some conditions. Like, let's say rows where calories are greater than 50 or heart rate is above 100. And that helps me find the most vigorous exercises. Now we can see that dancing and biking are both good, and actually I do like biking. It's just a bit harder. Now you can have as many OR and AND operators in your query as you'd like. The AND operator has precedence over the OR if you've got both of them in the same query, but you can always use parentheses to change the order of evaluation, just like with math expressions. Now I want you to try these out in the next challenge, and stay tuned for the next talk through where I'm going to show how to do some interesting things using this type column here. See you then.
Awesome. So I'm going to let you guys move on to the karaoke song selector. The goal of that challenge is to practice with your and or queries. No surprise there. But they're getting you started with saying, for the first step, select all the song titles. So what we're going to do is I'm going to give you guys time to work on each of the individual challenges after the videos, and then we'll do the project kind of all together, if that sounds good to everyone. So I'm going to open up the poll. No, I'm not. Zoom now hates me. Poll. Launch. I'll let you guys start working on that. I will leave this up on the screen share in case you need to reference that code.
Where?
Don't forget to vote in the poll as you're working on it. If you get stuck anywhere, let me know. Happy to screen share through it.
Well, can I screen share and talk through it?
Go for it.
So I just had a map. Well, not a map. I just had a table, but I had songs here. True.
Okay, and what table are we selecting? Okay, so select is always going to get columns. So we either need to specify what columns we want to select or all of them. Okay, and then go ahead and add in from whatever the table name is. In this case, it's songs. And then just delete out your where for now. Let's see if that works.
It did work for the table, but I still couldn't get to the next step. I didn't know the
Okay.
next.
So now it's saying, hey, only select the song titles. So how do we change that query to, nope. We only want to select the song titles, but we want to select all of the song titles.
Another star? Do we need another star?
Nope. We only want to select the titles. What are we selecting right now? What columns are we selecting right now?
Oh, so do we do name title?
What are the columns in our table? What are the names of the columns in the table?
Oh, ID, title, artist, mood, duration, and release.
Okay, and so we just said we only want to select the title. Okay, and throw a semicolon at the end. Okay, now, why don't you have a next step?
There's a comma after title.
Oh, thank you, Doug. There you go. Okay, so now we're only selecting the title. Now it wants you go ahead and next step to add in another select query. So we're not going to modify that one. We're going to do another select query that's similar to that one, but it's going to filter the data to only include certain things.
Okay.
So I'm actually going to switch over to my screen share just because we've got 10 people in voted. So what we are going to do. So first step is it wanted us to select only the title from the songs. Title is going to be our column. We see title here. We can look up at our database schema and see the title, and we select all of them, right? And that gives us all of the songs back, but only the data in the title column. Okay, now it wants us to select only songs where the mood is epic or the release date is after 1990. So we're still in a new query selecting only the title from songs, but we want to do that where something is true. What does it want? It wants where the songs have an epic mood. Okay, well, mood is set in this column called mood. So we're going to say where the mood is equal to epic, or where the release date is greater than 1990. So because we can line up the columns with the values in the column, we can see mood for this song is happy. But because it was released after 1990, it was released in 2011, you'll see that's in our results table. But something like Sweet Caroline does not show up in our query because it was not released after 1990 and the mood is happy, not epic. So the final step of this was, hey, Now we're getting really picky. We would still like to select the title from the songs where, and now it's saying where the songs are epic. So mood is epic, but notice what it's saying here, and it's released after 1990. So now instead of or, we're going to use our and say released after 1990. And that the duration is larger than 4 minutes. So I did this, and initially I went, why didn't that work? And then I read this note here that says, note, the duration column is measured in seconds. So we could say 4 times 60 and put in that value here, but SQL will actually let us get away with doing that math directly in there. So we can just do that 4 times 60, and now we should, it says less than 4 minutes long. So we actually want the less than operator. And now we've got it figured out. Any questions on that before we roll forward?
Yeah, fine. Oh, that's why. Fixed it. Never mind. Never mind.
Any questions?
I have a question. So, if we were working with SQL,
Yep.
what would, like in a job situation, what would we be given this database and we would need to pull information out of it?
Not necessarily. Sometimes so let's think to your initial capstone, right? With the bike routes. Well, you're going to have multiple bike routes that you want to store. So you need to identify, all right, in order to store all of those bike routes, what does my table structure look like? Well, I may need to name the route, but maybe I have an intensity of an easy, medium, or hard ride. Maybe I need to store the length of the route in miles. So I need to identify that and the data type that's going to store that. Oh, I'm also going to have a description of the route that I'm storing with it. So I need to design that table. Okay, well, now maybe I have an app and I'm keeping track of who has ridden those routes. So I'm going to need another table that's going to store all the users of my app. So the data itself may be given to you. It may be given to you in a spreadsheet. It may be given to you you may be connecting into a database that already exists, or you might be loading in that data yourself, or the user may be filling out a form and hitting the submit button, and that form is going to save into your database. So lots of different sources of the data.
So is this somewhat like where we couldn't find the API, but then we would kind of like create our own API? Is that what the same thing as this is?
Yep. A database is basically a API friendly version of a spreadsheet. Except that a spreadsheet starts to run into problems when you've got more than, let's say, 1,000 or 10,000 rows. Databases are set up to work with millions and hundreds of millions of rows without running into any performance issues, because instead of having to display all million rows in a spreadsheet, we are using a query language, SQL in this instance, to only get back the data that we actually are asking for.
Okay.
So while it seems harder to work with because, you know, we have to use this very specific syntax to insert rows or select rows or get that data back out with, because that is a little more restricting, it scales much better up to work with millions and millions of rows.
Makes sense.
And this will start to click a little bit more as we get into Node, because what Node is going to allow us to do is pull some information from our React app, send it through our API that we're going to build into the database, and then have the values that are stored in the database also show up in our React front end. So that's where we're headed next.
So we're gonna make so we're gonna have one of these. So we could make this show up in this whole thing right now where we're doing the karaoke. We can make this show up in React.
Yep. That's where we're headed next.
What would we do? That import thing at the top of the page?
Can't get into that yet. We've got 3 weeks of content, 2 weeks more of content, and then that will all make sense.
Okay.
This isn't, unfortunately, it's not like a 3-line thing. You're learning the database right now, and you've got React going on here, but you're missing that middle component, which is how do we build our own API? You've used New York Times, you've used someone else's API, and you understand how to get that data into your JavaScript. But what we haven't touched on is how do we build our own API using JavaScript in order to get the data from the database into our front end. And that's where we're headed in 2 weeks.
Let me see
Okay.
your screen again, Max.
You want me to share yours or you want to share yours? Do you want me to share mine or do you want to share yours?
I could share mine. The last part of this. How did you do it? The minutes part. Here.
So I did 4. No, you had it right. Is less than. Duration is less than 4 times 60 because we need to convert to seconds.
60.
But we don't want to do the group by there. We just did another and.
Oh, another and. Oh.
There you go. And don't forget your semicolon on 28 and on 29.
Thank you.
No problem. We good to move on? Any other questions? Okie doke.
I'm back with my table of exercise logs, and I've added a few more rows. Now, if I wanted to filter these logs to just show my biking logs, I could just add where type equals biking. Simple. It's getting sunny outside, so actually what I want to find is all of the outdoor activities, not just biking. So to do that, I can use the OR operator that we just learned, checking each of the different outdoor types. So type equals hiking, or type equals tree climbing, or type equals rowing. Unfortunately, I don't yet have a mountain or a tree or a lake in my home, so all of these are outdoor activities. All right, so that worked, but there is actually a simpler way to do this query, and that's using the in operator. The in operator will check to see if a particular value is in a list of values. Let me show you. So we'll take this query and I'll paste it, and then I'm going to replace this equal sign with in, and then put a parentheses, and then I'm just going to separate each of these strings with a comma instead of that whole long or type equals blah. Ta-da! Same results like we expected, but this query is easier to read and it's a bit shorter too. We could easily also do the inverse query if we just want to see the indoor activities. We just write not in. Ha. So that's just dancing, and I'll save that for the winter time. Let's change it back to in and our outdoor activities. And I'm going to show you something a little more interesting that we can do with in. First, I'm going to need another table of doctor recommended activities. I'll paste in the SQL for that. Let's see, where do we have it? Here. So here we've created a table of doctor recommended activities, which just has a type, which matches our type from up here, and a reason, which is why the doctor recommended it. Now, what if I wanted to see all my exercise logs that correspond to doctor recommended activities? Well, first, I might want to see what are those doctor recommended activities. So select type from doctor's favorites. Okay, biking and hiking. So I could just take this query and modify it and just shorten it to biking and hiking. However, if the doctor's favorite tables changed, like there was a new row added or a row deleted, then this query would be out of date. What I want is for this query to always be up to date with what's in this table here. So what I can do is use the in operator directly with the results of a SQL query, a select query. And it's actually very simple to do. I'll replace what's in the parentheses with the query that we did before. Ta-ta! Cool. So we call this inner query a subquery. It's the query that we're doing inside the outer query. And now this query will always pull based on whatever's in the doctor's table at the time. It will stay up to date. And this is a pretty simple subquery, but it could actually get really complex. It could be as complex as any of the queries that we've learned so far. Let me show you an example. What if we only want to select the favorites that the doctor recommended for cardiovascular reasons? So we could say where reason equals, and then we could paste this whole long reason in here, and we see hiking. But what if for some reason we didn't have the period in here? Well, now we actually see nothing for that query because it's trying to do an exact match and it can't exactly match that. So there are times like this when we want to do an inexact match, and we can do that with the like operator, which is a pretty neat operator. And so to do that, we're just gonna take this and I'm gonna replace the equal sign with like and get rid of, because all we care about is that very important word cardiovascular. That is what we're looking for. So we say cardiovascular and we also put a percentage sign on either side, which acts as a wildcard. So this should match any rows which contains the word cardiovascular anywhere, and it did. Yay! Okay, so that's pretty cool. Whew. We covered a lot in subqueries like. Hopefully you're pumped to try them out in the next challenge, or take a break, go climb a tree and come back. Either way, I hope you have fun with it.
Okay, so let's do a quick review of this video before we move in, because there's a lot that was covered here. There's a whole heck of a lot of stuff up here, but hopefully it's a good review. We created the table, including the including the columns, right? And the data types. Then we insert a bunch of data into those exercise logs. To see how that's working, we can just add a select star from exercise logs here. And if we scroll up over here, we can see, hey, here's all the data that got inserted into our exercise logs. That's everything in this insert into, as well as the columns from up here. Okay, now that we see all of that, there are some selects here where they said, all right, we want to select where biking or hiking or tree climbing or rowing. Excuse me. But that's pretty verbose. So what we can do is use a subquery. We can say, hey, let's say in and just list all of this out. So we don't have to keep saying type equals, type equals, type equals. We can almost use, this is kind of like an array, right? We can just modify our query and say, hey, where the type is in any of this list of the values. Okay, now that we've practiced with that inquiry, we move over and we create another table. It is very rare that a database will only have one table. So in this, we create a new table called doctor's favorites. We need to specify the columns and their data types, and then we insert some of that data into here. So we can see the result of that insert by looking at this select type from doctor's favorites. And if we wanted to, we could even see the ID and the reason as well. And you can see that query updates right here with the columns that we're querying out. Okay, now what we want to do is we want to see from the exercise logs. That's not this table, that's this initial table that we started from up here, where the type is in. We're using that new subquery again, and we're saying where the type is from the type in the doctor's favorites. Okay, well, the doctor's favorites was biking and hiking. So the results that we're going to get from this query are going to be all of our rows from the initial table that have biking or hiking as the type. So we're doing two select queries here, but using this in query, that's how we can kind of mash them together and select all of the data in the exercise logs where the type is in the type from the doctor's favorites table. Does that make sense? So the last thing we do is we say, hey, if we don't want to do an exact match, if we don't want to do a very specific sentence, what if we want to include where any of the reasons include the text cardiovascular? That's where we use this like keyword instead of the equals operator. But when we use like, it's kind of like we need to give it some flexibility. And so what this percent is doing is this is a wildcard operator. It's saying where there is any text either after it or before it. That's what the percent at the beginning and the percent at the end means. If there is any text before or after the word cardiovascular, we are going to match on that. So the only word that has cardiovascular in it is hiking. So the only data that we get back out of this entire table is the hiking type.
So I have a question.
Yep.
So she started off with the table, and then she then she did some selects, and then she created another table. Now, once she created that second table, I guess it piggybacks off the first table.
Only
so
if
that
you
she
write a
can-
query that are linking the two together.
Hmm?
Only if you write a query that are linking the two together.
Okay, and so then if she writes a query that are linking the two together, when she goes to pull data, when she goes to do another select, can she select and then pull something from the first table and then
Absolutely.
pull something from the second table?
Yep. So that's what we're doing here. So just because we've done all of these selects, let's say we don't care about the doctor's favorites anymore. We just want to see the exercise logs again. So if I add that command, and spell exercise right, why does select hate me? Now we get that entire table back again.
But she already had that in the, on the side. I'm saying like pulling something from what am I trying to say? Like pull something, like all of her tables are eventually when she puts in all the tables, let's say she had 5 tables. Towards the end, whatever information she's trying to pull together, she can pull from all 5 of those tables to show, you said, because this is like creating your own API. So she can pull from all of those different tables and then display the information, and it ties it all together, I guess I'm trying to say.
Yeah, so that's what she's doing here, right? She's saying, hey, select all the columns from the exercise logs where the type is in the doctor's favorites.
Mm-hmm.
So what she's doing here, doctor's favorites, their two favorite activities are biking and hiking.
Mm-hmm.
So if we look, here's our first table, but it's only showing IDs 1, 2, and 7 because those activities, biking, and hiking, are in the doctor's favorites table here and here.
Okay.
Right? So what she's doing here is she's filtering down the first table, which is exercise logs, which includes biking and tree climbing and rowing and hiking,
Mhm.
with the type that is in doctor's favorites, which is biking and hiking. So she's filtering the first table, the exercise logs, based off of the data that is in the doctor's favorites table.
Okay.
Great.
So this is to avoid making like one giant table. You can have, well, I guess we call these sub tables.
Nope, each one of them is a table.
So, but then each table helps with the sub inquiries. I guess.
Yes.
So you can, okay, so outside of her, I guess I'm trying to make it make sense. And if we were doing this and this was for like our project, so you said like the different routes. So I would have like a table that would have certain information and then pull some data and then add another table with more information.
Yeah, so in that example, let's say you've got two tables. One table is your routes. One table is all of your users. And let's say that you want to say, hey, I would like to see all of the users that have ridden this route.
Mm-hmm.
So that's when you could use this subquery to say, hey, go select all of the users where they have said they've ridden this route.
Okay. I got it.
Right. So in her example, she's saying, hey, here are all of the activities that I've done. I've done biking and tree climbing and rowing and hiking, but I want to know which of these activities are my doctor's favorites.
Okay.
And so that's when you get down into this biking, hiking. These are the three activities that the doctors have said are their favorites. And then she does another query where she says, hey, show me all the activities where the doctor said the reason why it's their favorite is because it's a cardiovascular activity.
Okay.
So that's the point of those queries.
Okay.
Okay, so let's, any other questions on that before we move forward?
Are we going to take break?
Oh, I was steamrolling right through that, wasn't I? Yeah, let's take a break. We'll be back at 7:40.
Thank you.
Thank you for the reminder, Larry. Sorry about that.
I have one question, Max.
Go for it.
In the like with the cardiovascular between the two percentages,
Yep.
Would that match just the word cardiovascular, or does there have to be something on the left and the right?
Let's find out. That query still runs. So yes, that does match. But if we take out an R, you notice that whole query disappeared. It's because it's returning no results. And if we add that R back in. With that said, I would be very surprised if there were a wildcard operator. Aha. I'm sending this your way. I can just pull it in here. There are more than one wildcard operators. So the star represents 0 or more characters. The question mark represents one single character. And then the % represents 0 or more characters. So you could use any of these syntax if you really wanted, cardiovascular with a period after it or something like that.
Okay, thank you.
No problem. Get through this a little bit quicker. We're going to do the challenge together and try and pick up the pace just a little bit here so we can get through things a little quicker. Okay, so the challenge here says we've created a database of songs and artists, and you'll make playlists from them in this challenge. And the first step, select all of the songs by the artist name Queen. So if we look, we've got an artist, we've got our name, country, genre, all of that. And then in another table, we've got our songs, right? And we kind of need to cross-reference them together. So what they're saying is select all of the songs by the artist named Queen. So what we're going to do is we are going to select the title from songs where the artist is equal to Queen. Okay, and that pulled out both of those songs. Great. Now, next step. Now you'll want to make a pop playlist. In preparation, select all of the artists from the pop genre. So we're going to say select artists, select says the name of the artist. So the column name is name from artists where the genre is equal to pop. And is it capital P? Capital P. Okay, so now we've got our artists, our pop artists, right? Nothing new there. That shouldn't be anything special. Select the column name from the table name where, and then we do our filter on that. So now, final step says to finish creating the pop playlist, add another query that will select the title of all the songs from the pop artists. So now we merge these together, right? We say select the title, but instead of where the artist is equal to Queen, we're going to practice with our in subquery. So we're going to say where the artist is in, and then we're going to say select we're going to say select artist from, or is it the artist name? Select the artist name from our artists table where the genre is equal to pop. Okay, so first query, we selected our title where the artist was equal to Queen. Okay, nothing new there. Then we selected all the artist's name where the genre was equal to pop. Okay, nothing new there. But then we merged these two together. We went to the songs table and pulled out the title of those songs where the artist in the songs table was in the name of the artist table where the genre was pop. Make sense to everyone? Any questions on that? And if we wanted to, of course, we could always modify this query and get the artist information or anything else from there.
It's gonna get harder, right? There's a catch, right?
This one isn't too bad, but we are going to try and pick the pace a little bit here. So let's move on to the next video unless there are any questions. Doke.
Let's continue with more queries of my exercise logs. Let's say that I want to see how many calories I've burned for each type of activity. We can do that with an aggregate query. say select type and then sum calories from exercise logs, and then we're going to group by type. Now I can see each type with how many calories I've burned total for that type of exercise. Now, do you notice how the column shows up as sum calories in the results? If we want, we can actually tell SQL to give that column a new name just by writing as and then giving it the new name total calories. That can make our results easier to read, and it also has another benefit, which we'll use later. So next, I want to filter the results to only show activities where I've burned more than 150 calories total across all the times I've done that exercise. It turns out that 150 calories is the amount in 1 ounce of dark chocolate, so it seems like a good amount to shoot for. Now, my first instinct might be using where to filter. Like if I took this query here and then said where calories greater than 150, then we only see dancing and we don't see biking, which we would expect to see. The reason we only see dancing is because it filters each individual row that comes in. And dancing is the only exercise where I burned more than 150 calories in a single log. But what I want to know is which exercise type or types have I burned more than 150 calories across all of the logs for that exercise type. We actually have to use something new for that, which is the having clause. To use that, we'll remove this where, and then after the group by, we'll write having, and then total calories greater than 150. Ta-da! Now we see biking, because now it's actually looking at the total calories, and I've indeed earned more than 150 over time in my logs. So as you can see, those two queries are actually different, but they are easy to confuse. When we use having, we're applying the conditions to the grouped values, not the individual values in the individual rows. We could use any aggregate function on a grouped column that makes sense. Sum, min, max, average, whatever we want to check. Let's do another example. So if we want to see the average calories for all the exercises where we burn, let's say more than 50 average total. Oh, that's all of them. So let's up it. 100 in the middle, still doing good. 70, cool. So you can see we can play around with that query there, get different results with that having. Now let me do something a little different. Let's say we want to see all the exercise where we logged at least 2 activities for that type of exercise. For that, we're going to use a count function. So I'll select type from exercise logs, group by type, and then having count star, doesn't matter what column, so we can just do star, greater than or equal to 2. Okay, so now we can see biking, dancing, tree climbing. I've done all of those at least 2 times. Makes sense because those are my 3 favorite activities in life. Besides coding, of course. Okay, so now you've seen having. Remember that it's easy to confuse having with where when using these aggregate functions. So think through your results and make sure they make sense. And now you get to try it yourself.
Okay, so what she just said there, that last sentence is the most important. Now you get to try it yourself. No, I'm just kidding. The one right before that. The whole point of having is we group having with an aggregate function. What is an aggregate function? All it's doing is it's adding multiple things together, right? It's taking multiple rows and giving us the value of that. So we just have to use having instead of where whenever we're working with an aggregate. Those aggregates are sum or average or count or any of those, right? Whenever we're trying to take all of our rows and aggregate that data together, that is what the group by is doing. That's what's aggregating it. And then the having is kind of the equivalent of the where filter on that. So when we move on, good example of this is we've got a books table. And if we just do a select star from our books, we're able to see all of the data in there, right? That's got the number of words in the book, it's got the author, and it's got the title of the book. But what if we want to find the total count of all the words the author has written? Well, what we need to do is we need to group by the author. And once we're able to do that, then we're able to filter that down by having. So what we're going to do is we're going to select the author and the sum of all the words the author has written as their total words. And the whole point of the as is so that we can reference this column in a minute. So we're going to select all of that from the books. And so now it's grouping it. But what we want to do is we want to say group by the author. So what that's doing, because we put that group by in there, now this sum is able to group down the sum of the words based off of our initial table. So it's important to keep in mind what our initial table looks like. So this is our initial one. And what the group by is doing is it's saying, hey, we want the sum of the words based off of the group of the author. So because JRR has 4 books here, group all 4 of those together, then add up the sum. Okay, now it would be easy to say where total words is greater than whatever we're looking for, right? But in this case, because we're using that aggregate, because we are taking all of these rows and adding them together, instead of using where, we have to use having. And so we're going to say having where total words, that's coming right from here, is greater than 1 million. And if I just comment this out, now we've got, okay, J.K. Rowling is the only one who has books that total over 1 million words. Go ahead, Doug.
Is the total words, does that only exist as long for the duration of this statement?
Yes.
For this query?
Yes.
Okay.
So if we did select total words from books, you notice the query doesn't return anything. It's because this total words doesn't exist.
Okay, thank you.
Any other questions on this? Do we understand the group by? We understand how that's impacting the sum query here. We understand having is like a where, except that it is used for these aggregates. And then what we're doing is naming the column here so that we can use that column here. We can't just say words here because we don't want to see where the words is greater than 1 million. We want to see where the sum of the words is greater than 1 million. So we kind of have to name the column here. Does that make sense? Okay. Next step, now select all the authors that write more than an average of 150,000 words a book. Your results should contain the author and the average words as an average words column. So similar approach that we're going to do here. We're going to select the author and the average number of their words, and we're going to name that column AVG words because they're telling us that's literally what we need to name it. We're going to say from books. We still want to group by the author of the book. And now we're going to say where the average number of words is greater than 150,000. And J.K. Rowling comes back again and happens to have this many average words. Good to go on that? Okay, moving on. So this is going to be a reading assignment. Basically what they're saying here is, and Christy, this kind of goes into your question, right? Of like, why are we learning this? Where does this database fit into all of it, right? Basically they're saying, hey, imagine you have this exercise app here, right? Software engineers are going to be building the back end, the server side logic or the API, and the front end engineers are going to be building out these charts and the forms and all of that stuff. But there's got to be something in between, right? There's got to be that API that is going to pull the data out using our SQL, out of using select queries, and getting that to show up. The other people who may be using SQL are data scientists, people who are dealing with millions and millions of rows of data, but they're trying to get information out of it, right? So data is the raw information we collect. Information is the actual use of that data. What is this data set telling us? That whatever it is telling us is converting that data into information. And product managers may be using SQL as well, right? They may be trying to figure out, hey, how long do people spend on these pages or different pages of our app? Or they may be figuring out, information collected from any different kind of source. So if you are interested in digging into that, this is just a quick little reading note there. Okay, let's sprint across the finish line. One more video, a challenge in the project, and then I will give you guys an option for class tomorrow.
Let's try a few more advanced SQL features. I've been logging heart rate for each of my exercises, and I haven't done anything interesting with this data yet. So now it's time. I did a little research on the internet, and I found that the maximum heart rate is 220 minus your age. So one thing I can do is query my logs to see if my heart rate ever goes above max, since that would be pretty scary, or tell me that there's something wrong with my heart rate checking device. Okay, to do that, I'm going to do a count star. So count star from exercise logs, and then where heart rate greater than 220 minus my age, 30. Woohoo, there's no results, and that makes my heart happy. Now, notice I'm using the subtraction operator, and in fact, I can use most math operators in SQL, like to add, subtract, multiply, or divide. And if I need to, just like in math, I can throw in parentheses and change the order of evaluation. All right, so we've confirmed that my heart doesn't go above max. That's good. Now let's look to see if my heart gets into the target heart rate zone. And that is 50 to 90% of max. So we're going to start with our count star, and we just need to change our where. So this time we're going to say heart rate is greater than, and let's look at 50% of max. So that's 220 minus 30. Okay, so you see I'm combining a few math operators here. And I'm going to also throw in the round function just to show you that we can use that function. It's pretty nifty. And then we're going to say and I'll just copy paste this and change it to less than 90. Let's go ahead and throw a equals in there. All right, so now we're checking to see 59% of max, and we see there are 4 logs that fall in that target zone. But what about my other logs? What zones are they in? We don't know. All we know is that 4 of them are in that target zone. The rest could be maybe they're 90 to 100%, maybe they're less than 50%. What I would really like to see is a summary of all my logs and how many were in each of the heart rate zones. Now that sounds like a situation where I would use a group by, like group by this column that says which heart rate zone this row is in. But I don't actually have a column like that to group by. Well, I can effectively create a column using the case statement. Now I'll admit that I find this the trickiest statement to use in SQL. So I struggle with it a bit, and don't worry if you find it a bit odd as well. It's similar to an if or a switch from programming languages, if you're familiar with those. Otherwise, don't worry about it. All right, so I'm going to use case, but I'm just going to start with outputting what we know, which is type and heart rate from exercise logs, and see what that looks like. Okay. Now, for each of these rows, I want to add a new column that says which zone the heart rate is in. To do that, I go into the select part of the query, and I'm going to write case to begin the case statement. Then I type when, and the first condition, which is checking if it's above max. So that was heart rate greater than 220 minus 30. Then I write then and an expression, which is just a string. So we'll say above max. Okay, so this is my first case. Now I'm going to keep going with my other conditions. So when heart rate is greater than 90, then we'll say it's above target. And then, so greater than 90, and then we'll say at that point, if it's greater than 50, we can say it's within target. And everything else would be below target. So I could do another condition for that, but I can also just be lazy or smart, however you want to think of it, and say else below target. Okay, now my conditions are all done, but I haven't told SQL what to name this new column. For that, I write end as HR zone. Awesome. So now for each of the rows, I can see the new column with a nice description of what zone they're in. Now that we've done that, finally, I can make a query that summarizes how many of my logs are in each of the zones. And that is a whole lot easier now that I've set up this case. I'm just going to take this query here, copy it, and I'm going to group by the new column we created, and then add count star, get rid of the heart rate, see what we have here. Aha! And now we see that we've got 4 below target and 4 within target. That's pretty neat, huh? That case statement, it is a tricky one, but it sure is handy once you get the hang of it. You may not use it all the time, but it's good to know just in case.
All right, how are we feeling? Feeling like we're all bored out of our minds? Good news is we only have, we're going to skip the challenge and go right into the project. And then I'm going to give you an option for tomorrow's class. So I'm going to go into the project here. Says we've got a bunch of data sets for you here, right? All of this stuff. Pick one of the data sets or create a data set like it, and then use an advanced select query to discover things about the data. What sort of collections, what sort of questions might you have about the data, and how would you use it in a business idea, right? So starting to dig into this and get the data out using case, using and, or stuff like that. So let's just pick, I don't know, Marvel character sounds good. Let's pop this open. And I'm going to just copy this whole statement and go back into my data dig and paste it in here. So all of this data is in here, right? So let's say I would like to know, let's say I would like to know the average weight of a Marvel character in kilograms. So I'm going to select the average weight from my Marvels table. And now I get out a basic average weight. Okay, so I can go in there and I can say, all right, I want to know where the average weight is. And I've been told you're never supposed to ask a woman her weight. So I will say where the gender is equal to male. Now I got null. Does anyone know why I got null here?
Are we using the star now?
Not using the star because I said average weight. because I want not the average of all the columns, I want the average of the weight column in particular. Why did I get null here?
Is gender even a value? I don't know if it is or not.
Yep, if we scroll up, gender is right here.
Okay.
Good guess, though. You're on the right track.
Is it like a total or something? Like, should it be something saying like, if it's the average, can you scroll back down real quick?
Gender isn't broken down between male and female.
Yep, right here.
Oh,
Because you're using where instead of having.
That's part of the problem.
Does case matter?
Case
Oh, no,
does
because
matter.
average weight, the average weight is not, okay.
Yep. And so because I'm filtering down what's included in the average, I am allowed to use the where there. So if I was when we need to use having instead of where is when you use where to filter down the input, you use having to filter down the results of that. So if I wanted to say let's say I wanted to, I can't think of a good example there, but because I only want the average to include the men in this data set, I am able to use the where. I would use the having if based off of the result of the average, I wanted to then filter that data down even more.
Yeah, I realize that. Thank you, Max.
So I can get some interesting information out of here. Let's say, in addition to that, I would like to know, let's select the count of everyone from the Marvels where the, let's say where the popularity is greater than, I don't know what they consider popular. Popularity is the second one. So 1, 20, 18. So let's just pick some random thing and say where the popularity is greater than 20. There are 9 Marvel characters that have a popularity greater than 20. And if I wanted more details from that, I could add in their name, and here are the popular Marvel characters. So this is just a chance to kind of play around with the data and be able to figure out like, hey, how do I group this data together? How would I filter that out?
Thanos.
Apparently pretty popular. Interesting that it's almost all
Bad guys.
all bad guys, yeah. Any questions on that? Anything that you want to play around with there?
Yeah, could you say set that as most popular and then get the most popular who are good guys? Get good guys, like how would you do that? So because you just created a setup that gets the most people with high popularity.
Yep, alignment is either neutral or good, or I imagine, oh, and bad. So let's say select name and their alignment. And that's going to show us that data. And then we could say where their popularity is greater than 20 and their alignment is equal to good. Or
It has to be more popular than Ghost Rider.
their alignment is also neutral. So now we're getting all the neutral and good popular Marvels.
My roommate was Cambodian and her son, he spoke Cambodian, but he could definitely say Spider-Man. So I think Spider-Man beats Ghost
That's
Rider.
what I was gonna say. That's terrible.
I did not make the data set. I
I
just
know,
copied and pasted it. Or we could use our in statement here. So we could say where popularity is greater than 20 and alignment is in are good or are neutral. That would be another way of writing it as well.
I only see men. The female, can we do something with female so we can see what, are there any females?
Select name and is it gender from our marvels where gender is equal to
I don't know any of them.
Jean Grey's a popular one. X-Men.
I don't know
Those
Venom.
are, I thought X-Men weren't Marvel.
X-Men's Marvel.
Oh,
It's in a weird, isn't X-Men supposed to be in like a parallel universe, but not multiverse? X-Men
yeah.
is definitely Marvel, but it's not in like the main Marvel that you know or think of.
Oh, okay.
Yeah, I think Marvel gave sold the rights to someone else before they started making their own movies, so they can't make X-Men movies.
Yeah, there's some weird, it's kind of like Spider-Man isn't technically Marvel because the copyright's owned by Sony, but then it's licensed to Marvel. There's some weird edge cases in the Marvel Cinematic Universe. Or maybe that's what it is that X-Men is part of Marvel, but it's not part of the cinematic universe. Who knows? Any questions on working with this data set, kind of playing around with it, understanding how we aggregate, how we filter? Make sense to everyone?
It definitely makes sense. It should just be interesting to try to, continue to choose the selects to pull the information out.
Yep, and that's all SQL is about, right? Is breaking out those queries and getting the data back that you want.
This reminds me, so is SQL like equivalent to a pivot table?
Kind of. It's kind of the combination of a filter in Excel with a pivot table.
Okay.
Okay, so here's where we are headed next. There are two more sections, two more lessons in Khan Academy. One is relational queries. This is where we are going to pick it up tomorrow. This is now how do we use our multiple tables to tie data in together. So we're going to go through this tomorrow, and then we are also going to go through the update and delete queries. And then finally, there's this what to learn next section. With that said, those are the only two lessons that we are going to cover, is this relational queries and the modifying databases with SQL. I will give you an alternative, though. If you are able to complete all of the challenges and lessons in relational queries in SQL, and also modifying databases with SQL, and screenshot the blue check marks to show that you've completed all of them, you can have tomorrow night off of class, and you will be marked as present for attendance. If you would prefer to go through them together, that is what we will be doing tomorrow during class. However, if you would like to kind of self-pace yourself, go through these lessons in advance, just send me a screenshot in Slack of this section complete and this section complete, and you do not have to show up for class tomorrow. Any questions on that?
Tomorrow's Thursday, right?
Tomorrow is Thursday.
Oh, so see you guys Monday.
So they should look, a complete section looks like this, except for that challenge and this challenge missing the check marks. So if you would prefer to go faster, if you think class is going too slow, if you want to just zip through these, you do have to get the challenges complete and checked off and If you are able to do that, you can skip class. If not, I will see you tomorrow.
As you know, when you can create a new column. You mind doing that one more time? When you name in a new column, like you creating a whole new.
Yeah, so when we are in let me
You
just
could probably do it for like all of the female superheroes, something like that.
so here is, I just pulled up a blank one. So when we are creating our table, right, we can call it Marvels, and that needs our data type. So we're going to say, oh, I am not.
Yeah, my bad.
Nope, not yours. Thank you for the reminder. Okay, so we're going to say ID. It's going to be the integer. It's going to be the primary key. And then we'll say name, which is going to be text. And then we're going to say insert into Marvels our values, our ID 1, and our name is Captain Marvel. And then if we want to do, let's say, which I will be watching after class tonight because apparently a new episode just dropped, and then we'll say
Miss Marvel or Captain America.
Miss Marvel.
Miss Marvel. I think new episodes drop on Tuesdays. Okay, so if we select star from Marvels, we're going to see our IDs and our names, right? But if we wanted to add a new column into that, we would just come up here and we can add in line breaks here to make this a little bit more readable. SQL does ignore line breaks. SQL will keep going until it sees a semicolon, and that's how it knows the statement is done. So it is less line break sensitive than JavaScript is. Okay, so if we wanted to add a new column here, like gender, and that's going to be text, we just need to make sure that when we're inserting those values, we also add that data in here. So here I'm going to say female, and male. And now, because we used our select star, we're able to see our data right there. But if we wanted to, for whatever reason, say only get their name and their gender, we are also able to modify our select to only have that data come out.
Right. I was actually talking about like when you want to rename a specific as, call it as something else. That was.
Oh,
you would just modify your column right here.
No, he's talking about when you did like some words as total words.
Right.
So you can just say like gender as identity, and that's going to change the output right here.
Okay, that's what I was kind of.
This is known as a column alias.
Column alias. Okay, thank you.
Thank you, Larry, for that clarification.
You're welcome.
Ariel, you're implying that a day without me is somehow a positive.
I literally made sure that everyone knew that's exactly what I was implicating when I said that. Yes.
Yes, so you get one night off of class from me if you are able to complete the relational queries section and the modifying databases section. That is what we will be covering tomorrow. I will say last cohort we had probably something similar, 15 students, and I think only 2 or 3 chose to go through them instead of going through class and doing them together. But we will be kind of keeping the same pace. And then next week, we're going to dive into getting our databases set up locally, running our SQL queries, and getting into database design.
Office hours.
Office hours. Do we want to create a poll or do we just want to say Sunday at 5?
Sunday at 5.
I'm off this weekend, so it's not much of a big deal for me.
Let me just create a quick poll before you all go.
If anyone's interested, I have varied hours this week too, either a capstone or go over this or previous homework assignments. I'll be honest with you, New York Times is not my jam, but the rest of it I'm pretty good about, I can help out with. So if anybody wants to reach out, I have a couple one-on-ones, but I've got plenty of room for more.
When Ariel says not her jam, she means that she would love to help you with New York Times. Just kidding. But I can certainly help with New York Times if you have any questions there.
How do we get to the lessons that are the optional from the challenges that we've been doing?
From the challenges you have been doing, if you're in any one in particular, up here, all of these are, I did not share. I clicked the button, but I did not click. So from up here, if you click on this intro to SQL querying and managing data, it brings you out to kind of like the syllabus view. And then what you need to complete is the relational query section and the modifying databases with SQL section.
Okay, thank you.
And I'm creating the poll for office hours. Just give me 1 second. You guys are welcome to get out of here if you want. I will post this in Slack. I'm just sending.
All right, everyone.
All right, good night, everyone.
Have a good night.
Night.
Good night.
Good night.
Have a good one.